also the important thing. So yeah, I hope this is something interesting to you, and probably something a bit different, and probably something that it's not something you are considering normally in your work. But yeah, as a question I asked earlier, so yeah, the telco business could be different in the future, and I will share more with you in this talk today. Right, so there will be three parts I will share. First of all, just give you a bit of context information and a background about telecom industry, and what's our story about cloud adoption. And I will use one example of the radio access network to give you a bit better illustration of that. And then I will share some of our cloud native journey, either something in production today or something that is within our research. And finally, I just want to share with you the broader view about what's the importance of the open source and cloud native community, even to telco. Right. First of all, a little bit about ourselves. So who we are. So BT Group is the UK's leading fixed and mobile communication provider, and there are a few brands. Probably you are familiar with them, but maybe not all of them, and maybe you don't know they all belongs to BT Group. So we have EE, and probably many of you are using the EE mobile services, and we also have the PlusNet, that's for the consumer, and the BT brand will be for the business. Although previously in the past, you might also have a home broadband from BT, but gradually in the future, you will get all the consumer household stuff from EE. And last but not least, just to mention OpenReach. OpenReach is dedicated on building the physical infrastructure, literally the fiber, the basically like the fiber to your home, fiber to your office, they all been built by OpenReach. And eventually all the network services delivered by EE, BT, PlusNet, they are all based on top of OpenReach. On the right, that's a bit numbers about our coverage in the UK. Next, just want to share with you some of our manifestos. I wouldn't go into the details, but generally, I would just want to throw out one key fact is currently BT Group consumes nearly 1% of UK's electricity, and 95% of that is coming from our network devices. So, well, I don't know what's your first reaction about that number, 1% of the country. Well, maybe the initial thought is that's a lot. Yeah, that's a lot. And probably you can imagine the scale of our infrastructure and the coverage of everything we have built. But actually, after a few seconds, maybe you will ask, okay, do you really need 1%? Is there any improvement or any optimization you can do to reduce that? I think the answer is yes, but it's not easy, and we are working really hard to reduce that energy consumption, and that's really something we will consider on every area we are looking at. Right. So just to give you a bit more background, but it's getting a little bit more technical here, is what's the key transformation trend in the telco. So the main theme will be around softwareization and cloudification. That has been happening in the last 15, 20 years, I would say. And specifically, what kind of changes they are? So first of all is disaggregated and open architecture. So what does it really mean is traditionally all the telco or telco network functions, they are being delivered as a fully integrated appliance, literally a hardware delivered to your telco premises. But now that is changing. So basically, it's the same idea as how we move our software architecture from monolithic one to the microservices one. It's share the same vision, but just need to know that that include like it's something. But something more different is the hardware plays an important role here. So that's literally this disaggregation will include the decouple of hardware and the software. And with that decoupling, probably you will say, okay, what to do with the hardware, right? So for some of the network functions, you still need some purpose-built specialized hardware to power the network functions. Most of them are the very intensive packet processing, but some of them, the rest of them could be actually running on top of the commercial off-the-shelf servers. So that's why cloud is what we will adopt. So now move to the journey of our cloudification. So everything started with physical network functions, so P and F, and with cloud. So initially we could literally have some of the services delivered from the vendor used to be bundled with hardware, and now they could be delivered as VMs. So we have VNFs. But that's not enough. So today we embrace cloud native. So what that potentially could be is all the network functions will be delivered as a container image, but how to put them together, because it's not just another wrapper of a piece of software. It changes the way how everything is being put together and actually how you operate them. That's really the key point here. Next, I will just use the radio access network as an example, give you a bit further illustration of that kind of evolution. So radio access network is essentially right. So your mobile device will connect to a cellular a cell tower, which is probably inside this building or outside this building, mounted on some of the cell tower in the suburban area, or could be some on the top of a building in some urban area. So those devices then being linked back to our mobile core using fiber, and the mobile core eventually will be connected to the internet. And in the UK, we have several mobile core distributed across the country, but that's literally how your data from your mobile devices is being sent to anywhere around the world. So what's the happening with that is that's literally it's called distributed run. And with the disaggregation, so what will happen next is C run. We call it either centralized run. So literally part of the function which was on the cell tower now has been decoupled and it's been placed in a more centralized location. For example, could be your local exchanges. That's with C run. And for the decoupled part, the BBU is called baseband units. Those units could still be hosted on some purpose-built hardware as appliance, but it is possible to be also hosted on top of a cloud. So that's what's come up with virtualized run. And the virtualized run basically means the network functions, some of those has been running as a virtualized environment. And what's next? So there are a few principles, not only disaggregation, virtualization, cloudification, but actually there has been more happening. So it's like openness, interoperability, and intelligent innovation. So those kind of things are really pushing us to, for example, how to improve the network performance and how to reduce the energy consumption and to deploy the services in with better flexibility. So all those kind of things is pushing us towards currently the industry is talking about open run. So open run, that basically means that first of all, further disaggregation has been happened. The baseband unit has been further split into distributed unit and the centralized unit, and it's been distributed across the network. And then those DU and CU, they could be virtualized. And more importantly, is this kind of architecture would allow something else to be happen. That's I will illustrate here. So that's a little bit further zoom in view about the open run architecture. So probably on the right top diagram, you can see the first one is you can achieve the benefit of resource pooling as however we deploy everything in cloud. On top of that, literally, because everything has been decoupled, we could scale up, scale out every individual component. So scalability, flexibility, all those kind of benefits could be achieved. And additionally, in this case, currently, it's not just a separation, but it could be more complicated. For example, you can connect one radio unit to multiple radio unit to a single DU and multiple DU to a single CU. Literally, you can have a more centralized coordination and load management. So there are tons of benefits could be potentially achieved, but the complexity is also a lot more than before. And just to also show you that on the bottom right diagram, that's an illustration of the architecture from the Orion Alliance, which is a kind of a standardization body pushing this moving forward. And we can see that literally apart from the actual radio unit, essentially is the antennas. Everything else could be hosted on top of cloud. And eventually on top of the cloud, there will be a service management and orchestration framework, which eventually will manage all the provisioning of the infrastructure, provisioning of the services, and the lifecycle management of that. So everything, and also load balancing, those kind of based on the network demand and throughput, all those kind of things could be achieved. But again, it's not easy, as I say. So basically, we have seen that the cloud has been something telco really need to embrace. So coming back to BT, I will share you, this is kind of our vision for the futures network. So you can see that regardless of the mobile services or fixed broadband services, every services eventually we believe that will be underpinned by a generic cloud infrastructure. So here we mentioned network cloud. Network cloud is what BT offer as the telco cloud. So basically is the services on top of that are the traditional telco services. But meanwhile, just worth mentioning that the edge computing is also happening there, because based on the nature of our network, it's highly distributed. So we have already have the different locations and premises to maintain our infrastructure. So it's naturally, it will be a good step to add some further computation capability and expose that to the customers and to the applications. So that's also linked back to one of the question I put together in the beginning. So the vision is probably you can say at the bottom. So we will drive the innovation to enable the API and network as a services. So basically is potentially in the future, if you develop a particular kind of application, and you might integrate your application with the telco API, so that you can reserve a specific amount of network capacity. So you could somehow guarantee that kind of connectivity is available for your particular application. So rather than nowadays, okay, just depend on the network. You might do some handling about, okay, based on network quality, you might adjust your application behavior or quality. But yeah, our vision is eventually leveraging clouds and leveraging everything on top of that very flexible architecture, that eventually the telco connectivity is not just a pipe. You might not know what's happening there, but it's a more controlled, it's we call network slicing, but I'm not going to talk more about that. But that's the idea. So literally, the telco will be somehow exposed to user, and to be consumed as just as how you consume public clouds nowadays. And of course, to achieve that, network optimization, automation, all those kind of things need to be available to support that. Right. So that's a bit fact about where we are today. So BT Network Cloud is the cloud which used for hosting our main business. So for example, probably if you are using the EE network currently, the mobile core is being hosted on top of our network cloud. So literally all the traffic you're sending out, if you are on EE network, it will go via our cloud and being sent out. So that's the domain one we define. That's the most critical part of our cloud infrastructure. But as part of our private cloud portfolio, we also have the network management cloud and also the enterprise cloud. And for some of our enterprise cloud applications, we also leverage public cloud to achieve that. And for the network cloud, literally, we have full stack control. So basically, from the data center, from the all the physical resources, up to the converged core, and up to the servers or the infrastructure, and up to the cloud layer, and up to applications. So we have the full control of that. But what's really important with that is this cloud platform needs to be really resilient. So it's something we could trust, because the telco infrastructure, telco service is really mission critical services. So the reliability will be really the key here. And meanwhile, it's about performance, since I think currently probably from a user aspect, you don't really see any, well, apart from coverage, right? But in terms of if you have good coverage, the network performance, probably most of the time you are satisfied. But to support that, the telco actually is working really hard to guarantee that, to give you more like a low latency, higher throughput, and high availability. And what's also important for us is the cost, because probably if you think about how much you pay for either your mobile network or your broadband, I don't think we will say there is a massive increase. But if you look at the traffic and all the different kind of internet or services you consume today, probably it has been many times more than even just a couple of years before. So how to reduce the cost is equally important for us to maintain our business. So what are the specific challenges for building the telco cloud? So that's a really high level layers of the network of the telco cloud. So the very first challenge is the very stringent performance. So as you probably hear what I said earlier, where we came from some purpose-built hardware. So basically that means all the CPU cycle, everything is very fine controlled in that kind of environment. But now we move to general purpose compute, the x86 CPU, and running on top of Linux. So literally, we need a lot of hard work there to maintain the kind of deterministics. So we need to make sure that the whole network services is really guaranteed for the performance, and also the network throughput. That's literally require us to have some really good, literally probably nowadays, if you consume public cloud, you don't need to worry about much about the connectivity. But for every piece of hardware we are building to host a particular network function, we just need to bear in mind that what's actually the physical network connectivity to that server. And if we migrate the service from one server to another server, we just need to bear in mind what's the connectivity available associated there. So performance is definitely one of our most important challenges. And secondly is this solution we build is integrated solution from multiple vendors, since it's not like many of the services available today, like it's built by the development team, and then it's being operated by the operational team. So in terms of DevOps, I think there are quite a few of you are from DevOps background. So this kind of organization structure, I guess you could understand that's the key for the success of that. But in our case, the actual development work for a piece of hardware is not from us, it's from the vendors. So in that case, probably if you are DevOps, you can understand there is always kind of a tension between the two teams because they have different goals. It's exactly the same true here, that we also have our challenges. So, and just following that, on the same topic is everything we are building is really run heavy. So in terms of the scalability, everything, so we need to really think hard to embrace cloud native technology, but what's the impact on our operating model? So we're talking about automation. We're talking about okay DevOps, but that every single change will have a big impact on our operation models. And also, last but not least, is we have the services. Well, we have the software components delivered from different vendors, but how about the kind of interoperability? If that's not the case, well, then we will need to think about okay. I think this thing has happened in the past, so that's another key challenges. And last but not least, the security. So there has been a Telecom Security Act coming up very soon. So literally in terms of the user data and how we do the isolation, how we do the separation of the user data going via the telco. And it's another challenge that we need to, it's actual complexity we just need to address as part of our telco cloud. And there are some of our goals on how to build and operate the cloud. I think we share among them, but the best of breed hardware and software, that's kind of our, I guess probably one of the unique challenges. And that's some of our technology stack we have been using today to build our network cloud. And I guess most of you are familiar with most of them. I wouldn't introduce more about that. Again, I just want to use Open Run as an example to demonstrate the complexity here. So on the very top, that's the network functions. And we can see after the disaggregation, after everything is from different vendors, okay, we need to address how the different components, they could be interoperable with each other, how they communicate with each other. But fortunately, that's something that we have the traditional telco standardization body doing that, and also including the current O-RAN Alliance. So this kind of horizontal integration is not too bad, but the vertical integration is really challenging. So just let me to give you a bit further information here. So for example, in terms of hardware, we need to support the network functions, right? So moving from dedicated purpose-built hardware, for example, delivered from Nokia, Ericsson, they are purpose-built, right? And once we move to the cloud, what we have is general purpose CPU, x86 from Intel. So surely it's a big jump. It's a big gap. It's something on the two extreme end of the spectrum. So how to address that gap? So there has been lots of workload specific processor coming up. Literally, normally we call that accelerators. So basically, that's kind of devices attached to the main server. So some of the workload will be offloaded to that accelerator to help the CPU. So CPU will do some relatively lightweight processing, and then we use the accelerator to do the most hardworking bits. And there are quite a lot of hardware vendors have been in this area. But the question is, there are a lot of selection of hardware vendors, right? And we also have a lot of selection of the software network function vendors, but how they maintain this kind of interoperability, it's quite likely to end up that one vendor, they will build their vertical stack, although they have embraced the cloud architecture and on some general purpose on some general purpose hardware on the commercial off-the-shelf servers, but eventually they still build their stuff on a specific theme. But so that could happen is we will end up that we buy the service from vendor ABC, and eventually we might end up with cloud ABC to just accommodate their different requirement of the software stack. So that's a challenge, but fortunately, I just want to point out that on the silicon area, in particular for ARM, that ARM has taken the initiative to build a kind of a library called ARM Run Acceleration Library. So basically, they are working with the silicon vendors that they will build a kind of standardized API or SDK to to collect all the different features, even though they are being implemented by different silicon vendors. But eventually, all the software vendor could just use that single library to consume the hardware capability. So somehow that's just make the complexity a bit better, I would say. Yeah. Yeah, that's just I want to say that that's a kind of vertical integration is our complexity here, and maybe yeah for the other applications you might don't need to worry about that much. Yeah. So well, I think I only got 5 minutes left, so I will try to keep that's a bit brief. So that's kind of yeah, that's kind of the journey we have. I mentioned earlier, from fully integrated vertical solution to be disaggregated, and the cloud has been part of that, but potentially there are still silos, I would say. So that's even, of course, not good for us as operators. So we are trying to push and have some things called like a more horizontal cloud. So literally, we own this cloud and we build this cloud and we leverage the best hardware. We leverage the heterogeneous hardware, including multi-architecture CPU, x86, and ARM, and the GPU, and also DPU and IPU, so different kind of accelerators. And we build this kind of cloud infrastructure, and eventually it could be consumed by the different network functions, either run or CDN or whatever. And the challenge for that is the same. Like it's first of all the vertical, the performance requirement, but also the horizontally things. This is so I would say currently, for example, we have 20,000 cell towers in the UK. So we could aggregate that in some places, but still we are talking about hundreds of cloud sites eventually. So here is one of our research piece of work. It's called NOMADIC. It's called Network-Oriented Multi-Architecture Distributed Infrastructure as Code. So basically, we have been trying to say, if we leverage all the good things from cloud native, if we use the infrastructure as a code, GateOps, declarative approach, and try to adopt the DevOps best practices and using CI/CD to automate some of the delivery. And we just want to say how to leverage those good kind of approaches and all the technology stacks to solve some of the complexity we have here. So the multi-architecture is one of them, because we have to be ready to make sure our stack is compatible with different hardware platforms. And finally, I just want to give you a bit broader view about the open source ecosystem. So probably open source ecosystem wasn't something important for telecom industry, but nowadays it is quite important, because I mentioned about this kind of vertical integration challenges, and lots of them actually have been addressed by the open source communities, since this is a very good way to get people together and to figure out what's a common framework we want to adopt, and to have to end up with some standardized interface. And also this thing could be complementary to the standardization and also accelerated standardization. And also at end of the day, that open source is really, yeah, it's to foster the technology innovation and the service creation. So yeah, if anyone of you has been plugged into any of those projects, yeah, feel free to reach out, and I'd like to talk more about that. And yeah, generally there are some really good projects from Linux Foundation and CNCF. They are really building something we are seeing that's good for the future and aligned with our vision. All right, thanks everyone, and that's what I want to share with you today. Thank you.
Okay, first question. How does energy use / overall efficiency of the new cloud-based architecture compared to the old way, which used a purpose-built hardware and software stack?
Yeah, very good question. The answer is, well, it's not as good as before, to be honest. But it could be a really really, it could be really difficult for us to say how much difference, because we used to have this kind of purpose-built stack, but I don't have a figure here. But if you look at the traffic increase of the network, that is also keep increasing. So literally, in terms of the infrastructure we have in provision, it's also a lot more than before. But generally, in terms of more looking into the technical view, if we do any micro benchmark, the energy efficiency, it's not as good as before. So that's the challenges we need to use to embrace some of the better hardware from the different silicon vendors. That's kind of a way to forward to solve that problem.
When you say worse, like, do you mean like sort of like 5% or 50%? Or 100%?
I think it's on the higher end. It's not the lower end. Yeah.
Okay.
It depends on the specific services. That's depends. But yeah.
Okay. We'll do one more. So what issues are you going to what? Oh, do you want to phrase your question?
Yes, basically. Right. Oh. So the main thing is about you transferring to the cloud. So for example, from your previous positions, okay, in terms of BT, right? BT has been more or less has got a lot of legacy systems in there. Oh, BT has got more legacy systems, right? Okay. So I mean, what sort of issues have you had transferring yourself to the cloud, transitioning yourself to the cloud from the previous legacy systems as such?
Yeah, that's another very good question. So that's why currently, in terms of how we reduce our energy consumption, one big thing is we need to switch off some of the legacy system. For example, by end of last year, we have switched off our 3G network. But currently, since 5G is available, we believe the fundamental infrastructure, the cloud infrastructure, should be shared for 6G, 7G. So that thing should be the same. So that's why 5G is important. That's literally we are trying to shape that kind of the architecture and the infrastructure which could be used for longer term. That's exactly the problem with the legacy system, because that's an appliance. So literally every 5 years we might need to get rid of them and buy new thing. But the cloud infrastructure, we hopefully the lifespan could be longer than previously.
Okay. Okay, please, are you going to stick around? We have more questions, but I think we need to move to the next speaker. So are you going to be around at the pub later? Okay, if you have questions, please address them at the pub. So another round of applause, please.
Thank you.
And pick them up. And now we are going to welcome Kate. So, Kate, the stage is all yours.
Kate Stankiewicz. If somebody wants to pronounce it properly. So today what we'll be looking for is geospatial analysis and how to find the sunniest bar in London. Since it's cloud native meetup, we would be using GCP for this and BigQuery. First, let's start from, and if it's the slide. It's not. Sorry, give me a second. We were talking about network and telecom, so. Okay, we can continue without it, and I hope my internet would figure it out. So basically, which company I'm from Sears. Sears is a consulting company focusing on technology. What we do is basically help people to migrate stuff. We help people with AI and many different things. I'm data solution architect, leading the EMEA region, and pleasure to be here. So, yeah, okay. Okay, let's try one more time. Okay, so this was slides about Sears. As you can see, we are focusing on cloud modernization, data analytics, applied AI, and many things. Nice thing, and I'm very proud of it. We will be just 20 years, like in 2024. So it's a solid number, and we've been awarded a partner of the year for GCP. Cool. So during the questions at the beginning, I asked why geospatial analytics is important, right? And basically one thing which is cool is that when we have a data presented in a tabular format, it's very cool to see it visualized, right? We're people, we don't have Google Maps or any other visual tool in our head, only our imagination. So geospatial analytics help you to visualize some stuff. And one thing which is like, I find it extremely exciting is basically John Snow. This is one of the clever physicians. He lived during the times of cholera, and basically he was able to understand where cholera originated from and how he did it. He basically took all the cases of cholera and put it on the map. And he saw that the biggest number of cholera is near the water sewage. So basically it spreads through the water. And here on the map, you can see Soho. So just fun fact, right? Another thing is pigeons. Why I posted pigeons? Because geospatial analytics was extremely popular, especially in the previous century. Like the whole idea of how it was developed and the biggest advancements were happening then. And this biggest warriors and biggest heroes were our pigeons, who were taking the pictures of Earth in order to draw the streets. And the last but not least is basically the satellite photo of Mexico. I don't know if you see here Mexico. I don't, but it's one of the first satellite pictures. So from this information, you can see that there is a huge history behind geospatial analytics. And geospatial analytics are crucial right now for the businesses because you can map out all your operations. You can see some interesting cool developments and like some interesting insights, right? And one of the things which we would be doing today is we would be finding the sunniest bar in London. And this will be a great example of using geospatial analytics. So why I'm showing here Google Maps? So when we think about Google Maps, the first thing which comes to mind is obviously how to find a path or route from point A to point B, right? Maybe sometimes when we are going and looking for some nice places to eat, we would also use Google Maps, but it's still about the point A to point B. But Google Maps is much more. And one of the things which they give APIs, they make it enable APIs, is environment APIs. And there are three kinds of, and we would be using the Solar API just to make you interested. So air quality is the first API. It gives you the insights on how good or bad the air in this specific region. The next one is pollen API. And I find it exciting because you can find the different plants or different pollens which are in this specific area, which I find is like really cool, especially if you're allergic. And Solar API, which we'll be using today. I found like, of course, a use case which I've chosen is like finding the sunniest bar. But there is more to this, right? Because you can use it for solar panels and more and more and more. Cool. As we have already established, we would be using Solar API. So why I'm having like the Simpson at home are here swimming in a lake? Because we're talking about bars, right? And again, I like interesting facts. I'm a little bit nerdy. So again, interesting fact is basically in 1814, London has been flooded with beer. And it was 1.7 million liters of beer. And 8 people drowned. And yeah, that was a lot of beer. And judge and jury ruled it as an act of God. So basically, for somebody, it is act of God. For the dead people, I think not so much. And sound, right? So we talked about bar, we talked about solar APIs, and now the sound. So originally I'm from Poland, and Poland has 1900 hours of sunshine, and compared to the UK, which has 1350 hours, right? The difference is quite big because this is like a whole month of sunshine. So I kind of understand why people in the UK try to find the sunniest bar, because why not, right? You want some more sun. Cool. So what we would be doing today is I will be showing a little demo. We would do a little bit of coding, and this is basically the output for which we would receive. So the elements which would be using is BigQuery, Solar API, and our imagination and the data set which I found. So what is the BigQuery? I saw the responses. Some of you didn't know what is it, but basically the BigQuery is, when you think about it, it's a data warehouse in the GCP. And when it sits in the Google Cloud, it's basically the heart of Google Cloud. It's one of the, to be honest, like from my personal perspective, it's really great tool. It's very easy to use and it's very straightforward. Why I'm saying that it's sitting in the heart of things is because everything is connected to the BigQuery, and you can easily call cloud functions, call, I don't know, some data governance, use some AI functionality, and so on and so forth. So it's huge. And you will see it today in action. Cool. So let's go to coding part. So I have found the data set, which is called pubs, obviously, and this data set contains pubs. And I found it from Kaggle, and you can see here that we have some name, address, postcodes, and the coordinates. As I have previously mentioned, we don't have maps in our head. So as a person who wants to see what have downloaded is right or wrong, or at least to see how it looks on the map, we need some tool to basically visualize this data set. And for this, I would be using BigQuery GeoVis. It's the free tool, to be honest, which is super cool, and it works smooth most of the times. I don't know why it's loading so long. And we can see our data set. A lot of pubs, right? We can see, of course, in London, the density here is huge. Birmingham. I found this area quite interesting. I don't know why there is no bars. I have no idea. I checked it in the maps as well. It looks fine, but yeah. And basically, cool. So we now have pubs. The next step for us is basically I want to pre-select specific area in London, which we would be processing, right? Because the Solar API, you need to pay money for this. So let's not to spend all our money on the Solar API request, and let's go to some fancy area in Mayfair. Cool. Looks quite okay. So let me run the pre-processing step. And as you can see here, it's like BigQuery, right? For those who don't know. I insert my SQL statement. Here we have dataset, which is called test K, and inside we have pubs as our table. So what I'm doing right now, I have selected the point in Mayfair, and I'm taking the radius of 500 meters, and I'm taking all the bars within this 500-meter radius. One of the cool things which I honestly really appreciate is that there is a lot of geospatial functions, and optimizations inside of a BigQuery. So it's very easy to use, and you don't need another like set of tools in order to work with this data. But if you, for example, want some advanced capabilities, because you can go deep, really deep with geospatial data, here I have only coordinates, you can use the extension called Corta, if I'm not mistaken with the name, yeah, Carto, sorry, all the time. Carto, and it's basically very easy to integrate with BigQuery as well. Cool. So let's select our pubs. Cool, and we have our pubs. We have selected a couple of them. Nothing have changed, right? And the next step for us, it would be to finally call our Solar API, right? So I would not try not to show the key so you would not spend all my money for Solar API. I hide it, so cool. So what we have here is a cloud function, which is a very short code, as you can see. The most of work here is my counter. I'm joking, of course, it's not the most of the work. I put additional like stopper here just to be sure not to spend all of the money. And what is happening here is we're parsing output. First thing, we're calling the URL of the API. We calling our Solar API. I'm giving the details of my bar and getting the response and parsing it. What are we getting out of it is max sunshine hours per year, which is exactly what we need. Of course, you can be very detailed and say, okay, Kate, but how are you sure that this bar has a rooftop? We don't. I just assumed that it will. Of course, if you want to make it production ready and whatnot, you can add additional data sets which will tell which buildings contain rooftops, but I was too lazy for this. Cool, so we created a cloud function, and now the next step is basically to call this function. And how we're going to call it, right? Normally, when you want to call something, you create like a Python script or whatever. Here, again, and you can see I'm a big fan of the BigQuery, and it's not connected to my job. I really like it, like personally. I used quite a few other clouds, and it was not that fun. So I really like it. So as I have previously connected this routine, which is called process in Solar, and this is our function. It was one SQL statement. I'm not going to repeat it here just for you to see it. I'm literally defining the endpoint of my cloud function and putting the name as well as the input which we're providing. So 2 coordinates, X, Y, and returning both. Cool. I hope all clear so far. So now let's call our function and process the data. I'm saving the variable in valsan. I know that it's not a very good name, and I heard there is a lot of DevOps people. Yeah, you would survive. But basically, the processing has finished, and while I was talking. And what we can see here is values of sunshine hours with that this current location receives, right? This building. Of course, if you would see, like if you would go further, there is other things which I didn't think about is, for example, what if the bar is a speakeasy and it, for example, in the, I forgot the name in English, it's like when it's underground, right? And it doesn't have sun at all. You can always go outside. Whatever. So it's just to simplify the process, right? So we got our values, cool. But now, let's say there was not like less than 20 values. I think it's 13, if I see it correctly. There was more. And of course, what we want to do is we want to draw our function, draw our values and see how it works. In order to do this, I would be doing a couple of pre-processing steps. So the first thing I would call, I would say that my top 5 bars, which has the most of the sun, I would get the numbers from 1 to 5. and the rest would get 100. Cool. So let's call it. I'm separating as a, like different steps just for you to see it, that it's usually more attractive. Cool. So now we received our values. Our data is saved in pub processed. And let's draw it then. So from all our bars, we have these 14 red dots. It doesn't say much to us, right? That's why, for example, for the quick demo, or for example, you want to quickly analyze some information, I really like BigQuery GeoVis, and I have created quite a few demos on this because you don't need to import any libraries in Python, connect to BigQuery table. You just literally write the SQL statement and it will be fine. So now we want to visualize it a little bit more because I don't see the bar, which is the sunniest. So what we would do, we would add one more step, is fill in color. And basically we can do intervals and select our field, which is val prior. So basically these are the priorities which I has given. And maybe let me show it on the table. Here we go. So you can see from 1 to 5, and the rest is 100. Cool. So now let's add different values. So it was 1 to 5. So it will be from 0. Maybe let's do like this: 1.5, 2.5, and the rest. The bar which is the sunniest, let it be green. The bar which is the second place, yellow. The third is red. The one which is from 4th and 5th would put it as a gray, and the last place it's black. Cool. So we can see now it's much more clear. Other things which are, like, for example, I didn't know exactly what level of complexity you guys, like what level of advancement in coding you are. So it's very simple example. You are literally calling the API, parsing the output, and drawing it on the map. There are many really cool things you can experiment with. And like, for example, I was recently searching, like working with a data set around housing in San Francisco, and one of my hypotheses was that the housing in everywhere, for example in Europe, depends how close you are to the stop, right, to the bus stop or to the tube, but it's not applicable to San Francisco. They don't care, probably because it's the US and they have cars. So let's find this bar. So it's, yeah, I don't know how to pronounce it. Yeah, Grapes Public House. J. Yeah, again. There. Okay. Cool. So let's see how it looks like. You can see this bar. I don't know if it has a rooftop. They didn't show their roof, but it looks kind of sunny, to be honest. And you can see why there is, like, I don't see any skyscrapers in the background, which will like put a lot of pressure on the building, and there will be no sun. So yeah, that's basically our bar. I hope you enjoyed it. If you have any questions, please tell me. But to summarize, Cloud Function, which was calling the API, Cloud Function was integrated into BigQuery. In the BigQuery, we processed our data through, we're just simply calling the function, and visualized everything in BigQuery GeoVis. And the dataset are found in Kaggle. So thank you.
Okay, we have a question. Any tips for productionizing this kind of system with BigQuery?
Versioning, right, with own control. It's also very easily integrated into the GCP. When it comes to the cloud functions, it can be risky to, for example, have a lot of load on your system and a lot of people are looking at the standard bar. So basically, not use a cloud function, but choose according to your load, maybe, for example, cloud run, which will like handle the bigger load, and you can customize it more. Of course, review all the assumptions because, as you see, I haven't assumed many things. And for example, the biggest thing will be here the UI, because this is BigQuery JRBs, right? Your users will not be running select statements on your database. At least you definitely don't want them to do it. And that's why I recommend people to go for UI and integrate it there.
How do your clients use geospatial insights?
The biggest number of clients which use geospatial analytics is the clients in e-commerce, for example, because they need to manage their warehouses, or if, for example, they're brick stores, maybe actual shopping locations. They can analyze the data where most of the clients are coming, what are the elements close and near to their like shops as well, to put it like more conveniently, or if they want to invest in some other area. Other things, I think, for the like some like app companies, when you, for example, like we've been doing this like we project with my company, and they have created an app which helps them to find the best like concierge service, right, which has the biggest number of reviews and so on. And they basically using the geospatial analytics in order to search the area around. And as simple as it sounds, right, you still need to identify and to scan, like see the location of the user and see all the shops around. Very simple use case, but still very, very cool application.
Cool. I think any last questions? Oh, yeah, I'll just come over the microphone.
Do you tend to build user-facing systems directly on top of BigQuery, or do you have another layer or a cache or something? If you're making an app that lets end users do this stuff, is there something in between, or yeah, direct to BigQuery?
So, like for example, in Microsoft will be like Microsoft SQL, right? So it's a table. In this case, of course, you can query the data straight from the database, but something needs to query this data, right? But and actually, one interesting thing as well, I think it's worth, because I haven't mentioned anything about security, and the security in BigQuery is really cool because you can control row-based as well as column-based, as well as like many other permissions. So it gives you the full flexibility of querying the data. When it comes to using it as an operational table, only in append, not for like updates. BigQuery is terrible with updates, and because it's not supposed to be, it's rather a data warehouse for your last steps as processing. If you want to use a normal, like if you want to create a normal operational database, use Cloud SQL or any other like normal ACID database.
Okay, so I guess you mentioned you use BigQuery quite a lot. So what are the limitations? What did you encounter any like limitations in terms of the geospatial analysis where you had to reach out for other tools?
Okay, I think that's it for questions. Another round of applause, please. Great. And that is it for this evening and for 2024. Woohoo! Yay! We will be back again, not the first Wednesday of the month, because that's the 1st of January and nobody, I hope, shows up here on New Year's Day. We'll be back on the 8th of January, but I hope you have a wonderful Christmas, wonderful New Year, and I'll see you again next year. Thank you very much. Please return these on your way out. Thank you. This was you.